Assalamualaikum and selamat sejahtera to those who are watching our presentation video for Mechanics 1 with the code of PHY110, especially to our lecturer, Dr. Aziz bin Lapid, or more known as Sir Aziz. First thing first, let me introduce ourselves. My name is Mohammad Firdaus bin Zamzuri with the student ID of 2024270696, and in our group of Group 2, we consist of 4 group members, which are Mohammad Irdreezal Miqail, Muhammad Fareezh bin Jusli, Clyrus Estevan Ignatius, and the last one is Muhammad Firdaus bin Zamzuri, which is me. So in this video, we are going to present our data that we got after conducting the experiment. So the experiment we are conducted is the Hooke's law experiment with the experiment number of experiment 6. So we start with the objective of the experiment of Hooke's law first. So what is the objective of the Hooke's law experiment? The objective of this experiment of Hooke's law is to verify the accuracy of Hooke's law statement. But what is stated by Hooke's law in physics? Hooke's law states that the force that are needed to compress a spring or to extend a spring is directly proportional to the displacement of the spring from its initial position. So from the Hooke's law statement, we have one mathematical relationships which is directly proportional, where the force that are needed to extend the spring or compress the spring is directly proportional to the displacement of the spring from its initial position. So in mathematics, let's say we have two variables, x variable and y variable. For directly proportional mathematical relationships, if the value of x is increased, the value of y will be increased too. And if the value of x is decreased, the value of y will be decreased too. That's the theory or concept for directly proportional mathematical relationships. So we know that from this theory or from this concept, the greater the magnitude of force that is exerted on the spring to compress the spring or to extend the spring, the larger the magnitude of displacement of the spring from its initial position. So in this experiment, we are trying to prove this statement. Is the Hooke's law statement correct?
For apparatus of the experiment is we use helical steel spring with supporting stand and scale, set of loaded weight with hanger, and weight balance.
The procedure is, first, the mass of the hanger, M hanger, was measured and recorded. Second, the weight of the hanger, W, was calculated and recorded in the table. Third, the table and the scale was adjusted so that the pointer on the hanger was near the upper end of the scale. When the hanger was unloaded, its position was recorded as X0. 4. A 10-gram mass was loaded onto the hanger and the scale reading X1 was recorded. The load was incrementally increased by equal amounts to obtain 8 data points before the lower end of the scale was reached. All data W and X1 were recorded. 5. The process was reversed by unloading the same loads as in step 3. The new scale reading X1 were recorded for each load. 6. The extension of the spring delta X was calculated. 7. The extension force acting on the spring F for each total load was determined.
The result for the experiment Hooke's law we recorded in this table. As you all can see, this is all the data we recorded. Analysis number 1. Plot a graph of the force causing the extension F against the extension X. Calculate the gradient of the graph and what value does the gradient represent. This is the graph that we get from the experiment, and the gradient is equals to 1.8. The gradient of the graph is representing the spring constant. Number 2. How much work done in stretching the spring through 0.20 meter. Find this from the graph. From the graph, we get the work done is equals to 1.44 times 10 to the power of negative 3. Question 3. How much energy stored in the spring when it's extended to 0.2 meter? To find the energy, we use the formula E equals to half times F times x square, which is half times 1.8 times 0.2 square. And the answer is E equals to 0.036 joules. Describe any error that may have occurred during this experiment. During the experiments, some error may have occurred. The extension of the spring might not have been measured accurately due to parallax error or the use of imprecise ruler. Similarly, force measurement could be inaccurate if the weights were not precise or if error occurred in converting mass to force. They could also be mistaken in recording the value of force or extension, which could affect the accuracy of the graph and calculation. What can you describe from your result about the relationship between the extension of a spring and the force causing extension? From the result, it can be described that the extension of a spring is directly proportional to the force causing the extension. This is evident from the straight line graph passing through the origin, which indicate a constant ratio between force and extension. This relationship follows Hooke's law, which states that F equals to K delta X, where K is the spring constant. Hence, as the force increases, the extension increases proportionally.
The experiment successfully demonstrated Hooke's law, which states that the spring of is directly proportional to the force applied, provided with the spring remain within its elastic limit. The graph of a force versus extension was a straight line passing through the origin. The gradient of the graph, which represents the spring constant K, was calculated as 1.8 Newton per meter. Several possible errors could have affected the result. The inaccuracy of measurements, such as a parallax error when reading extension or force. Other sources of errors may be minor errors such as recording data and assumption of perfect linear behavior of the spring. With this minor limitation, the general result obtained reasonably agree with theoretical expectation based on Hooke's law.
In conclusion of this experiment of Hooke's law, the experiment verified the accuracy of Hooke's law. The spring constant with the symbol of K was determined to be 1.8 newtons per meter, and the proportional relationship between force and extension was observed. The work done and energy stored in the spring were also successfully calculated. This experiment highlights the importance of accurate measurements and careful handling to minimize errors and obtain reliable results. With the objective of the experiment of linear motion. So what is the objective of this experiment? There are two objectives of this experiment of linear motion, which are the first objective is to investigate the relationship between force, mass, and acceleration. And the second objective is to determine the acceleration of an object under a varying force or under different forces. So from the Newton's second law of motion, it states that the acceleration of an object is directly proportional to the net force that are acted on an object and inversely proportional to the object's mass. From these mathematical relationships that we got from the Newton's second law of motion, we know that in theory or theoretically, the greater the magnitude of net force that are acted on the object, the greater the magnitude of the object's acceleration. And the greater the object's mass, the smaller the magnitude of the object's acceleration. So, in this experiment, we are actually trying to prove the statement of Newton's from the Newton's second law of motion. Is that statement correct or not?
The apparatus for linear motion experiment is Irdreezal rail, door, pressure tube, gliders, flag, photogate, maces, mass hanger, string, and pulley.
The procedure is: first, the linear air track set was assembled as shown in figure 4.3. Second, the pump was switched on and air was allowed to blow through the track for several minutes. The track was balanced by adjusting the screw on its leg so that the glider remained stationary and did not glide to either end when released. 3. A hook was inserted at one end and a flag was placed on top of the glider. 4. The mass of the hanger and the glider was measured and recorded. The length of the flag was also measured. 5. One end of the string was attached to the hanger and the other end was attached to the glider. 6. Masses of 20 grams were placed on the hanger and 80 grams on the glider. The string was placed over the pulley. 7. The glider was positioned exactly before the photogate. It was then released, and the time shown on the photogate was recorded. To prevent the masses from crashing to the floor and scattering, the glider was cocked by hand before the hanger reached the floor. 8. The procedure was repeated 2 more times to obtain average time values. 9. The slotted mass on the glider was decreased by transferring a mass of 20 grams onto the hanger. Step 7 and 8 were repeated. 10. And the last one. The procedure was repeated 3 more times, to each time transferring 20 grams from the slotted mass on the glider to the hanger.
This is the result for our linear motion experiment. As you all can see, the time was taken twice to get more accurate time taken data for different masses.
So that's the data we just got after conducted the linear motion experiment. Now, let's take a look on the analysis section. On the analysis section, there are 5 questions were asked actually. Now, let's take a look on the first question. The first question asking us to plot a graph of wake force versus acceleration. That's made the question asking us to draw a graph of wake force against acceleration. So as you can see here, this is our graph. So this is the first question. And then, from the graph we just draw, as you can see, the line is straight. If the line is straight in mathematics, this is defined as the directly proportional mathematical relationship. So the mathematical relationship between wake force and acceleration is actually directly proportional. So this graph proves this statement of Newton's second law of motion, where it states that in the Newton's second law of motion, object's acceleration is directly proportional to the net force that are acted on the object. Now, let's go to the second question. The second question asks, what does the graph tell us? Like I just said earlier, the mathematical relationship between force, wake force, and acceleration is directly proportional because of the graph line is straight. So, the graph tells us the relationship between force and acceleration of the object. Like we just give our answer on this slide, the graph shows the relationship between wake force and acceleration. The graph indicates that As acceleration increases, force increases proportionally in accordance with the equation of F equal to ma. So that's the second question. Now, how about the third question? The third question asks, determine the gradient. Whenever the question asks to determine the gradient, we have to use the formula of gradient. The formula of gradient is m is equal to delta y divided by delta x. What is delta y? What is delta x? Delta y means changes in the value of y. Delta x means changes in the value of x. So, changes, if you want to find the changes in the value of y, we have to look on the y-axis. If you want to know the changes in the value of x, we have to look on the x-axis. So, from the graph we just draw, like you saw before, our y2 is 0.206, our y1 is 0.010, divided by the changes in the value of x, or delta x, which is our x2 is 18.18, minus by x1, our x1 is 0.627. And when we click the calculator, our final answer is 0.0112. So from the graph, our gradient is 0.0112.
Question 4. Calculate the uncertainty of gradient. The formula for uncertainty of gradient is mmax minus mmin divided by 2, which is 0.0110 minus 0.0098 divided by 2 equals to 0.0006, and the final answer is m equals to 0.0112 plus minus 0.0006. Question 5. Briefly explain the relationship between the gradient from the graph and the total mass. The gradient of the graph represents the total mass of the system because the relationship F equals to mt times A show that mt equals to F divided by A, which is the gradient of the graph. A larger gradient means a larger total mass, and a smaller gradient means a smaller total mass.
The percentage difference between the experimental gradient m and the theoretical total mass mt was calculated using the formula. Percentage difference is equals to m minus mt divided by mt times 100. Based on the experiment, m is equals to 0.0112 kg. mt is equals to 0.0102 kg. Percentage difference is equals to 0.0112 minus 0.0102 divided by 0.0102 times 100 is equals to 1.96%. This indicates a small deviation between the experimental and theoretical values. The percent error reflects the accuracy of the experiment influenced by various factors. The several factors is air resistance and friction. Although an air track was used to minimize the friction, a small residual versus airflow might be affected. The result measurement errors also can affect the result. This is because timing inaccuracy from the photogate and slight errors in measuring the flag length and mass. To minimize the errors and improve the accuracy of the experiment, the track should be balanced though the glider can move smoothly. After that, in addition, precise instruments should be used to measure the time, flag length and weight. Also, repeating the measurement several times can lower the errors.
Now we are now at the end of the video of the presentation for Mechanics 1 PHY110. So what is the conclusion of this experiment of linear motion? So we conclude that in our experiment, the experiment confirmed the relationship between force, mass and acceleration as described by the Newton's second law of motion. The gradient of the graph closely matched the total mass with minor errors caused by measurement inaccuracies and setup issues. Despite this, the result validated the direct proportionality between force and acceleration. So that is what we conclude in this experiment.
So that is from us. Thank you for watching and listening. Bye.